The displacement of a particle is given, x is equal to e to the power minus 4t. We need to find the velocity. The velocity is the differentiation of this, or in differentiation with respect to time. So that will be minus 4 e to the power minus 4t. So basically what is significant here is the velocity is negative, and if we draw the displacement arbitrarily, just qualitative drawing, it's an exponentially decaying function, and gradients at, if we take gradients at various points, we can see the gradients are decreasing slowly, and the gradients are actually velocity at those points. So whatever the gradients at each point, let's t1, this is t4. So the significance is, let's say we take a section here on top. In a shorter time it travels much more distance, so the velocity is more, while here it takes, in order to travel the same distance, it takes more time, so the velocity is decreasing. So that's the significance. The velocity is actually, in effect, it's in the opposite direction, so that's why it's negative. Now if we look at the acceleration is again the differentiation of the velocity, so rate of change of velocity, and that is again, since that was a negative, that would be 16 plus, sorry, so that will be, yeah, plus 16 e to the power minus 40. So the acceleration is again positive, and we can also see that the velocity is actually, in terms of magnitude, it is 4 times the displacement, and acceleration again is 4 times the velocity, and that is happening because of this coefficient in the exponential. So whatever the coefficient is, since the coefficient is 4, it is getting 4 times in more. And also if we look at these functions, let's say this one, or let's call the velocity. So if we say what is the velocity in the beginning in the beginning, what is the velocity of the particle? So at t is equal to 0, v is equal to minus 4 e to the power minus 4t. So that is of course minus 4. But when the velocity is, when the time is infinity, that means after a very long time, the velocity will be 0, and of course the displacement will also, the velocity will be, sorry, 4 here, 1 over e to the power 4t, sorry, 4t here. So when t is infinity, when t tends to infinity, velocity will be 0, because this term will become infinity, so it will become 0. The acceleration will be also 0, and the displacement will also be 0. So, and they have initial values, say velocity is 4, the acceleration, the displacement will be just 1 here, because if we just plug in t is equal to 0, so those are the initial values. But finally they will all, because the particle will come to steady state, the displacement will be 0 after a very long time, infinity, because this exponential graph meets the horizontal vertical, I mean meets the ground, or rather this x becomes 0 after infinite. So it's an asymptote with this t-axis. The other observation is, we can see that this type of function, the velocity, acceleration and displacement, any of them do not change any sign. Like if it were a sine function, it would change. Let's say if it was a sine function, let's say 4 sine t, with changing time the sign would change, the velocity or the acceleration for each of them, it would change, so it would go both ways. But for an exponential function, the sign does not change, not for the acceleration, not for the velocity, and not for the displacement, none of them. So yeah.